Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is crazy permutations. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. Chef has two permutations, A and B, both of length n. Here, a permutation of length is an array containing each integer from 1 to n exactly once. Chef wants to transform array A into array B. For this, Chef can do the following operation. Chef can choose an index I and either increase the element at I by 1 or decrease it by 1. However, after every operation, this condition needs to hold. That is, ai is not equal to ai plus 1 and they should hold for all the values of I going from 1 to n. Now, intermediate values can become any integer. They do not have to remain between 1 or n. And A does not have to remain a permutation, but the final array A must be equal to B. Now we need to determine whether it is possible to convert A into B while performing the operations and maintaining this adjacency rule. We will print yes if it is possible, otherwise we will print no. For the input format, we have t test cases, and for each test case, we have three lines. The first line will contain the integer n, that is the number of elements both in array A and B. On the second line, we have the array A, and the third line we have the array B. As for the output, in a single line, we have to output yes if it is possible to convert A into B while maintaining the condition of adjacency, otherwise we will print no. As for the constraints, number of test cases will go from 1 to 10 raised to 4. Length of the array A and B, that is n, will go from 1 to 2 into 10 raised to 5. The elements in A and B will range from 1 to n as they are permutations, and all the elements in both the array will be distinct. Let's see some sample inputs. So for the first sample input, the elements in array A are 1 and 2, and the elements in array B are again just 1 and 2. Since both the array are already equal, there is no need for us to worry whether we can convert array A into B or not. Therefore, the answer is directly a yes. As for the second sample input, array A given to us is again 1 and 2, but in this case, array B is 2 and 1. So for this, we need to increase the value of first element in A by 1 and decrease the second element in array A by 1. With this, we can make this 2 and we can make this 1. But if you notice, if we try to perform any such operation, whether it be on the first element or on the second element, it ends up becoming equal to its adjacent element, thus failing the condition, and therefore the answer is no. Let's see how we can approach the solution. Let's take this example. So we have element b of I and we have bi plus 1. Now we want to convert our element, that is at ai and ai plus 1, to be equal to these. We want to convert ai to bi and we want to convert ai plus 1 into bi plus 1. Now if we ignore the adjacency rule, we can always do this because we can increase as many times as we want, or we can decrease as many times as we want. Now in which case will the adjacency fail? Now the adjacency condition says that ai should never be equal to ai plus 1. Now since all the elements are distinct, only these cases are possible. Either the first element is going to be less than the second element, the first element is going to be greater than the second element. Now if this case follows, that is, if the condition in array A is same as in array B, that is the first element is smaller than the second element, or the first element is greater than the second element, then whether we increase or decrease, it does not matter. Why? Because they will never cross each other. Imagine something like this. This is the height of element A and this is the height of element B. Now this is A1 and this is AI plus 1. Now if this inequality is followed by in array B as well, then whether we increase or decrease, they will never cross each other or they will never surpass each other because even B, the Bi, is going to be less than Bi plus 1. So it is never needed of Ai to cross the value of ai plus 1. The same can be said when ai is greater than ai plus 1 or bi is greater than bi plus 1. Again, in this case, there will never be a situation where the first element will have to cross the second element. But what happens if this is opposite? This is something that we have seen in the second sample input. Here, a1 is less than ai plus 1, but our b1 is greater than b2. Now, in this case, this element has to increase and this element has to decrease. And since we can only increase or decrease by 1, there will come a point where they will become equal and thus breaking the condition. So for this, what we can check is, for each element ai and ai plus 1, we will check if it holds the same equality in b. So if ai is less than ai plus 1, then it needs to hold that bi is also less than bi plus 1, and vice versa. We'll have to make sure that if ai is greater than ai plus 1, then bi also must be greater than bi plus 1. If this holds for all, we can say that our answer is yes. If that is not the case, we'll print no. And that will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. We take the input of n, then the input of our array a and b. Then we go over each indices from 0 to n minus 1. With this, we are checking the ith index and the I plus 1 index. If element at ai is less than element of ai plus 1, but this inequality does not hold in b, that is, bi is greater than bi plus 1, or the vice versa, where ai is greater than ai plus 1, but bi is less than bi plus 1. It means that at some point of time, while we are trying to match a to be equal to b, these two adjacent elements will be equal. Therefore, the answer is no. Otherwise, if all of them follow the adjacency rule or the inequality rule, the answer that we print at the end would be yes, and we can successfully transform A into B. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. We take the input of n, then our list A and B. We go over the indices from 0 to n minus 1. We check the adjacency rule that we saw in approach. If it breaks, we print the answer no and return. If at the end all the indices follow the rule, we print yes, and we get AC in our Python implementation. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.